Hello guys, welcome back to the LearnRISC-V YouTube channel. And in this session, I'm just gonna discuss briefly about the ecall instruction. So far, if you watched my other instruction set videos, I haven't covered this ecall, fence, and e-break. So in this, I'm just gonna briefly talk about the ecall instruction and uh, have a small demo on how to use this ecall, okay, and what it does rather than how to use. The demo would just cover like what happens when an ecall is invoked, okay. So these are the three things, or first the ecall would trap the processor, and ecall can be used to switch between privilege mode like the user, supervisor, and machine mode. And it can be the ecall is one which is used to implement the system call to access system resources at the same time to pass values or arguments between different privileges. Okay, so these are all the three basic uses of this environmental call. So I have created a application in the apps directory which is like machine user machine. So this code would just right after boot up, this code would be in the machine mode, then it would jump into the user, then again using ecall, it would jump into the, it will switch to the machine mode back, okay. So this, uh, so most of this would be a duplicate of other two videos in which I cover the uh, physical memory protection where there's a video on physical memory protection, and this is the PMP application corresponding to that video. And there is another application MTU, which is part of a video where I discuss about switching between machine to user mode. So this one, the current application like the machine user machine would be a, so 2/3 of that would be the duplicate of those two. So if you haven't watched that, I recommend you to watch that. But otherwise, if you know that, then you can just skip and jump to the third timestamp. Okay. So, uh, so as always, right after the boot, the execution would come to the start entry, and it would set the machine trap vector and jump into the app entry. And at here, the heart is in the machine mode, and then this is configuring the yum status with the privilege, previous privilege as user, so that when the yumret is executed, it would jump back jump to the user mode code, okay, and the address of the user mode has been set into the MEPC. And before we jump into the user mode, the user mode should have access to the memory locations to read write. That's why this PMP comes into picture here. Okay, so right after this jump into the user mode in the previous video, if you see, then when we try to write into this machine CSR, it traps because this is invoked from the user mode. But let's see what happens if we, what would be the difference between this trap and the trap that is created by the ecall. So first, let's build this. So I have loaded this. Let me just I'm just stepping into until this comes into the up entry. So it's configuring the PMP, and then so when I hit enter, now the emret would be executed and the execution would jump into the user mode. You can see clearly here. It's in this part of code now. Okay, so now the program counter is pointing to this location. Now if I hit enter, then the ecall would be executed. Now you can see the execution jump into the trap base because that's the address that has been set into the empty vec. So which would be here. So okay, now if you see the em cause, what has caused into this? Okay, that's exception 8. And if you go to the FE310 manual, so the exception 8 is the environmental call from the user mode. Okay, so the difference between the trap that would have caused by writing an or performing an unprivileged or performing an instruction that is not allowed in a particular privilege mode, if that is executed, then that would cause the processor, that would cause the exception of instruction access fault, or I think it would cause one or illegal instruction. But for the ecall, this is a different kind of exception, so that when we write the system call or while we handle the exceptions, we can clearly do what is needed for that. As I step in further, so it has, since this is an exception, it's jumped into the exception handler. And here, if you're going to implement some system call, we can check, like if the mcause is 8, then let's say that we want to get some value from the kernel address or so and so, then the parameters are passed from the user mode in certain registers, and the same would be used here to get the values from the machine, and you can return back into the user mode base for the system call implementation. Okay, but here I just want to show how the equal exception happens, and if you see here, I didn't do anything to handle the equal here. Okay, but as we write in write an OS or a higher level code, then we'll come back to this and try to write some uh, system call using this equal. Okay, yeah, thank you, and see you in the next session.